Okay, so we're going to be doing, we're starting chapter 5. This is going to be exponential functions and logarithmic functions. So today we're going to take a look at our exponential functions. And you can take a look at the guy over here. You can see the graph. This is going to be like a curve. And we did one of these back when we did all the graphing stuff. We just kind of looked at it. But we're going to go a little bit more in depth to it today. And exponential functions and logarithms are inverses of each other, so that's why they go together. Remember when we found inverses, we switched to x and y and did all that stuff? Kind of the same concept here with exponential functions and log functions. So it's called an exponential function because our variable is in the exponent. Okay, so you'll notice at the top, before we get to the graphing part, we're going to just take a look at evaluating an exponential function. So we're given that f of x is equal to 81 to the x power, and it's asking us to find the value of this function given a certain x. So we're going to start with the first one. It wants me to find f of 2. That means I want to know what is the value of my function when x is 2. So we're going to put that in 81, but in place of x, we're going to put that squared. Even though we don't know that number off the top of our head, because that's going to be a big number. So we'll do it in the calculator, and 81 squared is 6,561. Okay, just finding the value of it, just like we would with any other function. You just plug the number in the parentheses and simplify it out. Now, when we do these, we like to keep things in fraction form, especially when we get to the graphing part, because it's easier to tell where a fraction is rather than a decimal, or where it should be close to. So when we plug in this next one, we're going to plug in the -1, so that would become 81 to the -1 power. Do we remember that? It's been a while with negative exponents. What does that do? Turns it into a fraction, so it just becomes 1 over, not 18, 1 over 81. And then we would leave it just like that as a fraction. What's different about number 3? What is my number in my parentheses? It's 0.5. Well, we don't know how to raise something to the 0.5 power, do we? But we do know that 0.5 is also what as a fraction? 1/2. So what we can do when we plug it in is raise it to the 1/2 power. And this is something that we have done before. We might not remember the fractional exponents. That bottom number is the root that we're going to take, if you remember that. So that we're going to take what root of 81? It's the square root, yep. And then we're going to raise it to the top power, which would be 1, and the square root of 81 is 9, and 9 to the first power is just 9. Okay. So I want you to try the next one, number 4, but this time your decimal is 1.5, so we need to turn that into a fraction. So think about how to turn 1.5 into a fraction, and then I want you to simplify it. Again, because we can't do it in our heads. We can't raise something to a decimal power, so we change it to a fraction. What is 1.5 as a fraction? 1 1/2. And then if I wanted to turn that into an improper fraction, do you remember how to do that? Multiply and then add, so that would give me 3 over 2. So then it turns into a problem very similar to number 3. So the bottom number of that fractional exponent is the root that we take. The top number is going to be that power that we raise it to. So we're going to take the square root, and then we're going to raise it to the third power. Square root of 81 is 9. What is 9 to the third power? 729. So just to evaluate exponential functions, just put the numbers in, simplify it out, but we want to keep everything as a fraction, no decimals. Now, when we get to the graphing, we have these imaginary lines that we don't draw, but they are there. They're called asymptotes. Okay, and that's a line where my graph is going to approach, but it will never cross. If you'll notice in that exponential function, it's a curve, and that is going to, depending on which way it curves, sometimes it's going this way, sometimes it's going that way, sometimes it's upside down, but it's always going to approach a number but never quite touch it. Everybody ready? Okay. So let's take a look at the first one. We're going to graph the function 3 to the x power. Okay, an exponential function 3 raised to the x power. And we're going to think back to when we did our graphing before. We're going to do a t-chart. What 5 numbers did we choose always? -2. There you go. Okay, so we're going to choose those same 5 values. And when we plug these in, we want to keep them all. I mean, it's not going to be wrong if you put it as a decimal instead of a fraction. To me, though, it's just easier to tell about where that should be if I have it in fraction form rather than decimal form. So what we're going to do is we're going to plug in each one of those x values to fill in our t-chart, and then we'll talk about graphing it. We'll talk about the asymptote, where that is, what that means as far as our graph goes. Each one of these functions, if you change one little bit about it, it's going to do a transformation like we did before, where we moved left, right, up, down, got wider, smaller, okay, all kind of stuff like that. So if I do -2 and I plug that in, what is 3 to the -2 power? 1/9, yep. And then if I plug in -1, 3 to the -1 power is going to be 1/3. Thank you. If I plug in 0, what is 3 to the 0 power? Anything to the 0 power is 1. And then we'll plug in 3. 3 to the first power is 3. And then 3 to the second power is 9. All right, so we're going to start trying to graph these. Now, 1/9, is that going to be closer to 0 or closer to 1? 0. So when I graph this, again, this is just an approximation because there's no way we could be exact with this. I'm going to plot the point -2 and +1/9, which is going to be a point right above my x-axis somewhere, if my graph will let me do this. Oh, come on. Right there. So, real close. Just not letting me put a dot for some reason. Oh my goodness. This is really strange. I don't know what's going on here. I can kind of see a dot, but it's not showing up. There we go. Somewhere around there. Okay, very close to the 0, but not quite 0. And then we'll plot the point -1 and 1/3. So here's my question. Is 1/3 going to be further away from 0 or closer to 0? Think about 1/9 and 1/3. Is 1/3's bigger, right? Okay, so it's going to be just a little bit further up. Not much, okay? And sometimes we can't really see how much further up it's going to be. And again, those fractions are all just approximations. We get them as close as we can. Then we have the point 0, 1 that we will plot. And then the ordered pair 1, 3. And then 2, 9. Now, before I connect these dots, I want to think this way. So if we're looking to the left of our graph, it looks like it's going to continue this way, right? But what I want to think is if we chose an x value even further out, let me say I don't know, let's go -5. Okay, if I were to plug in -5, that's going to be 1 over 3 to the 5th, which is 81, 243. Does that equal 0? It's still slightly bigger than 0, right? If I picked a number 3 to the -10th, now I don't know what that is off the top of my head, but I know it's 1 over 3 to the 10th. Does that reach 0? So here's a question. Is there any number that I can substitute in for x? So raising 3 to any power that would equal 0 or go smaller than 0, meaning a negative. No, it's just going to get smaller and smaller, closer and closer and closer to 0. So our asymptote in this kind of graph, I'm going to draw a dotted line. Okay, you don't have to draw it. Just want to kind of show you where it is. But our asymptote is going to be the x-axis. That means our graph is going to approach that number, that position, but it will never cross it. So it is never going to go below that x-axis. So when you graph this, you need to be very careful that you're connecting your points. But you get close to the x-axis, but you do not go over. And once you get past that last point, you can just put an arrow. Okay, it's going to get closer and closer to the x-axis. And it is very hard for us to draw stuff like that on a grid that we have a specific number of space, give a number of space. Okay, we can't represent those with dots. Okay, but just to understand that it is going to continue to go closer and closer and closer to 0, but it will never equal 0 and it will never go below 0. Now that asymptote can shift. It can shift up, it can shift down. It just depends on what we do to our exponential function. Does everybody kind of get the idea of the way the graph is supposed to look? All right. Let's look at number 2. Okay, same thing. We're going to use the same 5 numbers. -2, -1, 0, 1, and 2. But this time, my base, the number that I'm raising my power to, is a fraction. So it's going to change a little bit. So we still want to do a t-chart. We still want to plug those values in. I'm going to go -2, -1, 0, 1, and 2. But what happens to that fraction when I raise it to the negative power? It's going to turn into a whole number. Like the whole number, when we raise it to a negative power, turns into a fraction. So if I have a fraction and raise it to a negative power, think about this. Okay, we got to bring back what we did a long time ago. When we had fractions, we would give both the numerator and the denominator that exponent. Both of them are negative, which means we have to change both of their locations. So that 4 squared would go to the top, the 1 squared would go to the bottom, and that would become 16 over 1, which is just that whole number 16. That make a little bit of sense? Kind of remembering some of the stuff that we've done before. Now, sometimes you're going to get numbers that are not going to fit on your 10 by 10 grid that I give you, and that's okay. We know about where it should be, and we know how high it should go. So like in this case, 16, I'm obviously not going to be able to plot that point because it's not going to fit on my little grid. But I know that it's going to go high quick. What if I raise 1/4 to the -1 power? What does that become? 4. 1/4 to the 0 power is 1. 1/4 to the first power is just 1/4. And 1/4 to the second power is 1/16. So what I want you to do is plot those points. You can leave that -2 and 16 off because obviously it doesn't fit on our graph. So start with the -1 and the 4. Plot your points. Think about your fractions. In a fraction, especially if the numerator is 1, which it will be in most cases here, the bigger the denominator, the smaller that fraction is. I think about a pizza. Would you rather cut it into 4 and split it or 16 and split it? You're going to get more pizza if you cut it into 4s. what I want you to do is just kind of look at your two graphs and compare what did changing my base from a whole number to a fraction, what did that do to my graph? It just flipped it around, right? Yeah. Let's see. So negative 216 is not going to work. So negative 1 4, 0 1, 1 1/4, 1 1/6. I'm sorry, 2 1/16. Here we go again. For some reason, it's not wanting me to put those dots there. Come on. As good as it's going to get. But think about negative 2 and 16. That's going to be pretty high up on the next one, right? So it would be like way up here next to where my work is, wouldn't it? You see that dot that I just put up there? So think about that graph. It's going to get really high really quick, and then it gets really small really quick. That's why they're called exponential, because things happen exponentially, meaning quickly. So we're going to graph. Again, I'm not ever going to equal 0, and I'm not going to get negative. So it's going to just get as close to that x-axis as you can. And then you'll notice that this basically reversed the graph, flipping it around the y-axis there. Makes a little bit of sense? Okay. I want you to try number 3, but be very careful when you're plugging your numbers in because your exponent has a negative in it already. So go ahead, choose those same 5 values. Plug those in for number 3. Taking that exponent and making it negative, we're going to see what it does to that whole number base. Whole number 5. What I want you to look at is compare, once you get the graph for number 3, compare it to the first two. Does it look like the first one where our base was a whole number, or does it look like the second one where our base was a fraction? Which direction is it going? Okay, it's a whole number base, but we changed the exponent to a negative. Mm-hmm. No, it's 5 to the negative x, but if I plug in a negative, what do those negatives turn? They turn positive, don't they? So that would turn into 5 squared, which is 25. Again, not going to fit on my graph because it's too big, but we know about where it should be. What if I plug in negative 1? I think canceled out, didn't it? What is 5 to the negative 1? 5, yep. 5 to the negative 0 would just be 5 to the 0, which is 1. 5 to the negative 1 would be 1/5. And 5 to the negative 2 would be 1/25. Again, obviously that negative 2 and 25 is not going to fit on my 10 by 10 graph, so I can't graph that one. But I can do the negative 1 and positive 5. Then 0 and 1. 1 and 1/5. 2 and 1/25. And for some reason, every time I get close to the x-axis, it does not want to put a point. There we go. And then again, we're going to go real high real quick because we have to shoot up to number 25. and we're going to get real close, but we don't ever cross that x-axis or go below it. No, don't touch it or go below it. So we saw a base of a whole number. We saw a base of a fraction. We saw a whole number base with a negative in it. Which one does that look like? Does that look like the whole number base or the fraction base? Fraction, because if you put a negative in the exponent, it makes it a fraction. What's different about number 4? I added something in my exponent, right? So what we want to do is take our same 5 values, plug those in, but we want to see what adding that 1 in my exponent will do to my graph. What kind of shift does that make? Okay. Then we'll add something in a different position and see what change that makes in our graph. And then we'll put a negative in front and do that. Okay, so kind of just looking at all of the changes that could happen to these exponential functions. Yep, and then you just do those 5 squared. Okay. While you're working on that, I need to look at my calendar. See when your next quiz is. So next week we will have that block schedule on Tuesday, Wednesday, Thursday. So I'll only see you Tuesday, and I won't see you again until Friday. So we will not have a quiz or anything next week. So your quiz is going to be the 16th of April. Is going to be the quiz for this first part of this chapter. So not next Tuesday, but the following Tuesday. All right, so if I plug in -2, that's going to be 2 to the -2 plus 1, which is actually 2 to the -1, which would turn into 1/2. Okay. Then if I plug in -1, that's going to give me 2 to the 0, which is 1. What do I get if I plug in 0? 2 to the first power. And if I plug in 1, I get 2 squared, which is 4. And then if I plug in 2, that's going to give me 2 to the third, which is 8. So -2 and 1/2. Come on. There we go. -1 and +1. 0, 2. 1, 4. And 2, 8. Okay, so when we do this, do you notice how that +1 shifted my graph like wider almost? It's not as intense in its curve. Okay, so that's what that one is going to, it's like a compression because it's going to make it wider. Okay, not that you have to memorize the movements on these like we did before. We're just making sure we take a look at it. So also, if you look at 1, 2, and 3, where did my graph cross the y-axis at 0, what? 1, right? And so this one crossed it at 0, 2. So you would think that it shifted the whole thing up. It didn't. It just kind of stretched it out and made the curve less intense. Do you see the difference between 4 and 5? Yeah. Where is my +1 this time? Is it in the exponent? No, it's behind it. Okay, so plug in your same 5 values. let's take a look at that. This one is going to have a little bit different of a shift to it. That's just halfway between 0 and 1. Either way, whatever works best for you. Yeah. On this one, you're going to get some mixed numbers. It's okay if you leave it as a mixed number, but you can also turn it into an improper fraction. For this, it's going to be whatever's easier for you to know where it goes on your graph. Okay, so if leaving it as a mixed number works better for you, that's perfectly fine. If you'd like to turn it into an improper fraction. And again, if you prefer decimal because that helps you, that's fine. To me, it's just a little bit easier to see where things go if they're in fraction form. It's just my opinion. Still choosing the same 5 values. So you could also just 1/4 plus 1 is just 1. But yeah, if you wanted to add it the other way, you would have to do it. So if I plug in -2, that is 2 to the -2 power first, and then add 1. What is 2 to the -2? 1/4. Okay. You can get common denominators, but think about your mixed numbers. 1 plus 1/4 is just 1 and 1/4, isn't it? Okay, so you can also leave it like that. Think about 1 and 1/4 though. That's going to be above not just 0, but above what number? 1 and 1/4 is going to be slightly above 1. All right. Then if we plug in -1, 2 to the -1 plus 1 is going to be 1/2 plus 1, which is 1 and 1/2. If you prefer mixed numbers, that would be 5/4, and that would be 3/2. Okay, that's up to you though. What about if I plug in 0? What is 2 to the 0? And then 1 plus 1 is 2. What is 2 to the first? 2, and 2 plus 1 is 3. And then 2 squared is 4. 4 plus 1 is 5. So look at your y values. Okay. Compare it to what we did the first time. What number is it not going to go below? It's not going to go below 1, right? Because we're taking 2, we're raising it to some power, and then we're adding 1. That means it's always going to be larger than 1. So this time, our asymptote is not the x-axis anymore. It's not where x is 0. It's going to shift to where x is 1. Okay, so let's go -2 and 1 and 1/4 is going to be above here, maybe. Come on. Okay, -1 and 1 and 1/2 is going to be halfway in between 1 and 2. 0, 2 is here. 1, 3 is here. And then 2, 5 is going to be here. So this time, okay, we don't draw it, but our asymptote is going to be that, I can't draw it here, let me get a thinner line, is going to be here. So I cannot ever go below that line this time. When you add or subtract a number after you raise a base to a power, that's going to shift your asymptote either up or down, depending on whether you add it or subtract it. So you just want to be careful that when you graph this time we don't go below that one line. We get close to it, but we do not go below. because I can't raise 2 to a power and then add 1 and get something that's less than 1. Does that make a little bit of sense? All right, last one. What's the difference about this one? I put a negative in front. Question, is that negative in parentheses? No. So whatever number I put in the exponent, does that affect the negative on the outside? If it's not in parentheses? No. Okay. So let's talk about it. I'm going to get the start button and I'll let you finish graphing it and see how it looks. I'm going to show you what I mean about not affecting it. So because that negative is not in parentheses with that 2 and then the x on the outside, that negative is basically going to be like a -1 there. And then we're going to raise 2 to whatever power we need. So in this case, every one of my answers is going to be negative. What is 2 to the -2 power? Okay, so that's going to be -1 times 1/4, which is just a -1/4, right? Okay, so go ahead and finish those. Sketch that graph and let's see what that negative does to it. You might have an idea of what it does based off of our previous graphing. Once you find your values, plug them in. And then take a look at what that did to our graph. What do I get if I plug in -1? -1/2. And if I plug in 0? And if I plug in 1? And then plug in 2? All right, so this time, -2, -1/4, that's going to be just below 0, isn't it? -1 and -1/2 is going to be in between 0 and -1. 0, -1. 1, -2, 2, -4. Can I ever touch the 0 or go above it? No. Okay, so basically what this did is do what to my graph? It flipped it upside down, right? We still have an asymptote of 0 that we cannot cross. So just think about the shift, where everything is and what effect it has on your graph. Right? Not that you have to memorize those, so just be very careful when you're graphing these using the same 5 numbers, -2, -1, 0, 1, and 2. And it will always be some sort of curve, whether it's curved to the right, curved to the left, a little bit wider, a little bit more narrow, or flipped upside down.